Hello everyone, this is if you like our first pre-lab video. Now you may have noticed that the labs are starting to get more sciencey, if that makes sense. Okay, so not so much common sense anymore. Maybe you're okay with density and separating mixtures, but this is kind of like a first kind of truly kind of chemistry-like experiment. Okay, so for future labs I'll do kind of a pre-lab. They match up pretty well with what we do during the regular semester. So what I'll do, I'll give you my regular semester pre-lab, and it pretty much carries over to your experiments. So remember what you do with these experiments, yeah? You obviously download the packet right here in front of me from Canvas, right? So go to that Chemistry 101 group site, download the experiment, and then head over to the Pivot site, and it's actually like a demo of kind of a student doing the experiment. You record data in the packet here, and then you kind of just analyze that data, okay? So, you know, it's not so bad in terms of, you know, emulating a lab experience. I kind of like it. It's better than a virtual lab. You've seen those things? Yeah, not good. All right, so what I'll do, I'll move over to some notes here. So I'm going to switch between the packet and some written notes, okay? So, you know, you may want to watch this before you do the packet. So I'll try and write neater than normal. So the energy content of food, right? So the objective, all right, find the energy released per gram. So that's going to be in, you know, units of kilojoule per gram when various foods are burnt. Okay, now the thing about this is relates directly to food labels. Okay, so on a food label it tells you, in America of course, you know, calories. That's our standard unit of energy for food, right? It says how many calories per serving usually, right? So we'll convert calories to kilojoules and, you know, servings to grams later using a conversion, and it's usually like 28 or 30 grams per serving usually. Check a packet, right? If you check a packet of cornflakes right now, it will say so many calories per serving. We can, you know, do our experiment in kilojoules per gram and work it backwards essentially, okay? So here's a little bit more on that. So background. So question, how does Jenny Craig, Seattle Sutton, whoever you like, right? How does Jenny Craig measure the energy content of food? Like we just said, calories per serving, right? Okay. Now, very, very careful, right? When she says calories, right, it's actually calories with a big C, right? Which is 1,000 calories with a small c. There's a very, very important difference there, right? So what you see on the back of a food label is kilocalories essentially, right? So it's 1,000 calories if it's got a big C, right? And when we have that calorie, 1 calorie with a big C equals 4.18 kilojoules, right? Now that is in your packet, right? So if we look through, actually it's not in the packet, it's on the video, right? So if you watch the video, it's actually part 1 of the video. All right, so, you know, watch that first part of the pivot, you'll see this conversion factor. Okay, now, so as I mentioned, we'll get kilojoules, we'll convert to calories using this relationship, and then maybe, you know, if we know how many grams are in a serving, calories per serving. All right, now here's the key thing. All right, key. Let me move this up a little bit. Okay, key. So just like the labs, right? Oh, sorry, lectures. Key. The energy, and it has the symbol Q, right? So Q is the universal symbol in science for energy, right? Units of joules, right? We saw the joule before. So the unit of energy is the joule, which will pop out of our experiment. We'll convert it to kilojoules, convert it to calories, okay? The energy contained within any food is released as heat when, let's move this out of the way here, the food is burnt. Now if you watch those videos, that's the essence of your experiment. Okay, so if I did like a little kind of pictorial representation of what goes on, and we would actually make this apparatus up in lab ourselves, all right? So it's called the, you know, the Pepsi Can Calorimeter essentially, right? So you can get a vessel, any kind of vessel, right? So they have that nice kind of metal container it looks like in the video, okay? So that's your can, right? Or your cup or whatever, right? You have to excuse me. I have a voice control on my camera and it sometimes thinks I say words I don't. Okay, so back to it. So we have a can, okay? And in that can we have our water, right? So that's H2O of known mass, right? And that's going to be M later in our math, right? Okay. And then we have a thermometer or a temperature probe. Okay, now in the lab, that would go off to a graphing apparatus and we can actually make a graph, which is nicer. It's better than the one we see in the video, which is just measuring the low and high temperature by eye with just a regular thermometer, right? But so just think of that as a thermometer. Okay, so far so good. Okay, now that would be clamped in the lab, so that's off bottom, so you're measuring the temperature of the water. Then down here, you have a little food sample, right? And you weigh this by difference before and after heating, all right? So say it was a peanut, you weigh the peanut in the holder before you set it on fire. You do the experiment, the peanut burns and energy is lost from the peanut and it goes into the water, right? Fair enough, and the temperature of the water will then go up. There's a relationship between the heat that goes in and the temperature. They're not the same unit, joules and degrees C, but obviously if it gets hotter, the more energy has gone in. So we'll see that relationship in a second. Okay, so transfer, what's lost by this minus is gained by this plus or Q, right? So the temperature goes up, all right? So we record the temperature change, okay? So if I was on my graph over here, you'd see a rapid rise in temperature, the peanut would go out, and then it would slowly decline like that. You're looking for the biggest change in temperature, right? So on your video, they show you the initial temperature and final, so delta T equals final temperature, maybe it's 35 or something, minus initial, maybe 25, so a difference of 10. Okay, so you see a difference in temperature between before and afterwards, right? So that's the experiment in a nutshell. You weigh the food in the holder, you set it on fire, the temperature of a weighed amount of water goes up by a certain number of degrees, and then afterwards, very important, you weigh the food again, right? And then the difference in mass you record, so that's the mass of the food burnt, right? Okay, so there's two masses in this one, be careful. There's the mass of the water, which we'll use for calculation of Q, and then there's the mass of the food, which we'll learn, you know, is the grams of food burnt. So we do kilojoules per gram of food burnt, right? Okay, so we get our data. So hopefully you've seen the video, you've got this data set, right? So let's have a quick peek at the sheet here. Okay, so I'll kind of switch backwards and forwards, right? So you have various foods, you'll do this, you know, multiple times, so you're going to kind of, you know, hopefully you're able to kind of write this by hand and scan it or in some way edit it. Remember the PDF viewer, I think it's called, a PDF reader is good for editing PDFs, which this is, right? Okay, so almond chips, peanut, pistachios, you can do the same technique every time. So maybe I'll run through it with you once for one of the foods, right? So for almond, initial mass of the food and holder, final mass of the food and holder, subtract those and you'll get the mass of the food burnt. And that'll be like a small number, maybe 0.10 something grams, right? So that's going to be a small number. So you subtract these to get the mass of the food burnt, right? Now, because water has a known density, right, you can turn the volume of the water in the can into the mass of water in the can. Should we do this in lab, I'll actually have you go off script and just weigh it directly, but they want you to work out from the volume of the water in the can what the mass is. So say it was 50 milliliters, it'd be right around 50 grams with all the sig figs, right? Okay, then you measure the temperature of the water before and after the food's burnt, subtract for the change in temperature. All right. Okay, so that's all the information you need. All right, and you do that for each video. Now remember, when you watch those videos, I did this, right? So the alcohol one is a demonstration, and then just click the drop-down menu to select the other foods, and you can see the masses and temperature changes, etc. Okay. All right. So back to it. So the math, right? So the math. So the energy that goes into the water, okay, come down. So the energy that goes into the water can be calculated. So the energy, Q, that goes into the water equals CP, which is a conversion factor. It's like you go to Canada, there's an exchange rate between dollars and Canadian dollars, right? Or Mexico, there's an exchange rate between pesos and dollars, right? So the exchange rate between Celsius and joules is for water, and everything has its own unique heat capacity. Joules per gram degrees C. That means I put in 4.18 joules of energy for 1 gram to go up by 1 degree C for water. So that gets us from joules to degrees C. Now obviously the more water you have, it's not going to get as hot, right? So like a big old full pan of water takes, you know, more energy to boil than half a pan, right? So that's where the mass of the water comes in, right? So that's mass of water in the can. That's going to be around 50 grams if you use 50 milliliters. I can't remember exact volume they used in the video, but in lab we use 50 grams of water, all right? All the sig figs, don't forget. And then the change in temperature, right? And when we do the packet later with thermochemistry, we'll see this again, right? So this is kind of coming a bit early in terms of the syllabus, but it's not so challenging. Change in temperature, delta means change, right? Okay, so you put those in, what you got? Joules per gram to degrees C times gram times degrees C. You get joules, right? So you get Q in joules. And if you look at your sheet, where did it go? Oh, it's underneath. I'm hiding it underneath. You get Q, right? So you can do the math here. Q equals Cp times M times delta T. But it doesn't want joules, right? It wants kilojoules. So then divide by 1,000. And you know, unlike the quiz where I'm kind of testing that, you can just move the decimal place for this one, right? So say you get 200 joules, right? That's 0.200 kilojoules. Fair enough, right? Okay, so show the work, okay. And then we want an apples per apples kind of comparison, right? So we want how many kilojoules in a gram of food, right? So that number there is that gram there. So don't confuse the grams, right? So the grams of food is a small number, the grams of water is a big number. We use the grams of water here and the grams of food here. So just take that number, divide it by however many grams of food you actually burnt. That's kilojoules per gram. Fair enough, right? Okay. Now, having done all that, the last thing we have are the questions, all right? So the questions are actually not so bad, all right? So I'll just talk you through them a little bit, okay? So rather than write on the piece of paper, let's just write on here. So which food had the highest energy content, right, and the lowest? So when you write this, you'll have a big numbers and small numbers down here at the bottom, right? So just tell me in words what the biggest is with the value, okay? In science, we always back up our argument with numbers if we can, okay? So the highest was this one, it had this many kilojoules per gram. The lowest was this one, so many kilojoules per gram. Okay, so let's take a quick look at these last few questions here. Okay, so number 2, basically, I want you to figure out how many calories in a 50-gram bag of peanuts, right? So you have to use 3 conversion factors, right? So first, 1 packet or 1 bag, 50 grams, right? Okay. Then calories to kilojoules, because in your experiment you got kilojoules, right? So 1 calorie, 4.18 kilojoules. In your experiment, right? So this is your number from your experiment. What did you have? Well, you had so many kilojoules per gram, right? So that means 1 gram equals however many kilojoules. So you found that from your experiment, right? Now if you think about it, it's a conversion factor chain, yeah? So we've got to go from experimental answer to 50 grams essentially in energy, or vice versa actually. So the other way to do it is kind of more kind of common sense. So 50 grams per packet, all right, times, well, what's got grams up here? There's your conversion factor, right? So you can have grams down here, kilojoules up here, all right? And then calories. And you're left with calories per packet. Okay, so nice and easy. You can convert anything to anything if you just link the chains together. Right, okay. So next one, I'm going to write not biology. So some of those nuts and other foods on there have higher fat than others, and you can kind of use your common sense to figure out which, right? Okay. So based on the results for this experiment, those kilojoules per gram numbers, think about which foods have the highest fat, how that relates to kilojoules per gram, and then tell me why fats are well suited to storage in the human body based on the results from this experiment. Okay. Last question. You're going to be asked, how many grams of protein at a certain kilojoules per gram provide the same energy as peanuts, 25 grams, right? So here, it's a little different. It's not a conversion, it's kind of an equality, right? So the energy in the peanuts is the same as the energy in the protein, right? If we look at our numbers, if it's protein, 17 kilojoules per gram, right, times the number of grams, 17 kilojoules per gram times the number of grams is the amount of energy in the food, right? So if it was 2 grams, it would be 17 per gram, it'd be 34 and 2 grams, right? Okay. So you can work out the total by the amount per gram times the number of grams. Now this comes from your experiment, right? So your experiment, whatever your number was, that's from your data set, right? Times, they say 25. All right. So this is what you have. You have this value in your experiment for peanuts, right? So your kilojoules per gram number times 25 equals 17 kilojoules per gram times the grams of protein. So just rearrange that to find the grams of protein. Okay, show the work. Oh, pick that up. Show the work, okay? Show the work, and you're good, okay? So have this to me by the end of Tuesday the 16th, 11:59, okay? So it gives you plenty of time to do it, okay? All right. Any questions? Ask them on discussion, okay? If you've got questions about any lab, bring it up on discussion. If you are a student who's answering a question that somebody asked, you get a point of extra credit. So let's share the wealth. Hey, extra credit socialism. All right, share the wealth on that discussion. Or if, if it's a little bit more complex or you don't feel comfortable doing that, office hour, okay? So office hours, as always, 9 on Thursday. Make sure you sign up through Teams if you haven't done so. And check the announcements for that from the first week of class. Okay, I'll see you on the next one.